So this is going to be video 2 in the series that we're going to do on solving systems of linear equations in two variables. Okay, so we're going to look at the two algebraic methods for solving. So in the previous video, we looked at kind of just an introduction to systems of equations. We looked at what the solution to a system of equations was, what it looked like. And then we talked about solving by graphing. So remember, the solution to a system of linear equations in two variables is the point where the two lines intersect. And you could see that from the graphing method. The graphing method is fantastic, especially if you have a graphing utility or like a calculator, Desmo, something like that. If you're doing it by hand, it's maybe not the best method for solving because you have to be super, super precise. With that said, we have two backup algebraic methods. So let's go ahead and look at those. So we want to go to the whiteboard. And let's start. So there are two methods for solving. Let me go to the black ink. There are two algebraic methods for solving systems of equations. And remember, we're talking specifically linear equations in two variables. Okay, the first method is substitution. The second method is addition, or you can see it called elimination. And once you see us work through it, you'll see why it kind of has two names. So we're going to start by looking at the substitution method, and then we'll move over and we will look at the addition or elimination method for solving. Okay, so first up, substitution. So steps for substitution. Okay, the first thing we want to do is solve either equation for one variable. And this, I would say it doesn't matter. It does not matter which equation, which variable, but be kind to yourself. Look for equations where one of the variables has a coefficient of 1 or -1. Those are the easiest ones to solve for. Okay, again, it doesn't matter which equation or which variable you solve for, but look for things that make life easier. So again, look for equations where one of the variables has a coefficient of 1 or -1. Those are just the easiest to work with. Okay, the second step is substitute this equation into the other equation. So whatever equation you solve for in step 1, you take that result and you plug it into the opposite equation. What this does is this gives us an equation in one variable that we can then solve. So that's what you do. Solve the new equation. Bless my heart. There we go. Solve the new equation. And then step 4, use this value. So you plug one equation into the other, solve that result. Okay, that's going to give you one value for one variable. Okay, so use this value to find the other variable. So the whole point in substituting is you're creating an equation that has one variable. You solve for that variable and you use that to find the other variable. Check your answer. And then I'm going to add a 6th step here. Write your answer as an ordered pair. That's kind of my own little quirk. I really want your answer to be written as an ordered pair. Okay, so let's look at an example. I think the easiest way to do this is to dive in with an actual example. Okay, so the first example says solve by substitution. So we're going to solve by using substitution, and we have the equation or the system of equations y equals 3x minus 7 and 5x minus 2y equals 8. Well, if you go back to the steps, the first step here says solve either equation for one variable. Well, if we look at what we have here, the first equation has already been solved for y. So what I want to do is I want to take this value for y and I'm going to plug it into the other equation for y. So we're going to take 5x minus 2y, but now we have that y equals 3x minus 7. And then I'm going to set that equal to 8. And so what we've done is we originally had two equations and two variables. Now we have, by substitution, one equation and one variable. I can solve this last line. I can solve this for x. And once I have a value for x, I could plug that back into either of the original equations and I could figure out what y is. So let's go ahead and use what we already know to solve this for x. So the first thing I want to do is distribute. So I get 5x minus, I'm going to distribute my 2. So negative 2 times 3x is negative 6x. Negative 2 times negative 7 is plus 14, and that equals 8. So I can combine like terms over here on the left. 5x minus 6x is just negative 1x. So I'm going to write it as minus x plus 14 equals 8. All right. Now, negative x plus 14 equals 8. I need to isolate the negative x. I'm going to do that by subtracting 14. 14 minus 14 is 0. Negative x plus 0 is 0. 8 minus 14 is negative 6. I'm going to divide both sides by negative 1, and I get that x is equal to positive 6. This is great. So this is like the first half to my ordered pair solution. But I now need to use this value for 6. I'm going to plug it into either of the original equations, and then I'll solve for y. So let's say we take that first equation. Y equals 3x, but x is now 6 minus 7. So y equals 18 minus 7. So we think y equals 11. So we think this is the solution, 6, 11. But let's check our work. Okay, now remember from the first video, we check our work by plugging this ordered pair into both equations. If this ordered pair makes both equations true, then we're good. We can say with confidence it's the solution. So anywhere I see a y, I'm going to plug in 11. Anywhere I see an x, I'm going to plug in a 6. So I'm going to get 11 equals 3 times 6 minus 7. So that's going to give me 11 equals 18 minus 7. 18 minus 7 is 11. So the first equation is good. Now for the second equation, we're going to get 5 times 6 minus 2 times 11 equals 8. So let's see, 5 times 6 is 30. 2 times, or negative 2 times 11 is negative 22. 30 minus 22 is 8. 8 equals 8. This ordered pair right here, 6, 11, satisfies both equations. So we can say with confidence that this is, in fact, the solution to the system. Let's look at another example. Let's say for this time, again, we're going to solve using substitution. Wow, bless my heart. So we're going to solve using substitution. And this time we have the system 3x plus 2y equals negative 1, x minus y equals 3. Okay, so we go back to the slide with the steps for substitution. The first equation says solve either equation for one variable. And then I added a note. Look for equations where one of the variables has a coefficient of 1 or negative 1. So when we go back, if I look at this second equation, x has a coefficient of 1, y has a coefficient of negative 1. I'm going to solve this first equation for x. So to do that, I add y to both sides, and I get x equals y plus 3. I'm going to take this value for x. I'm going to plug it into the other equation for x. Okay? So the first equation is 3x, but x we now have is y plus 3. And then the rest of the first equation is plus 2y equals negative 1. So by taking the second equation, solving it for x, I did that by adding a y to both sides. I now have a value for x. The value for x is y plus 3. I'm going to take that value, plug it into the opposite equation, which would be the first equation. And what I've done is I've now created an equation in just one variable, y. So we're going to solve this equation. I'm going to start by distributing a 3. 3 times y is 3y. 3 times 3 is 9. And then the rest of the equation is plus 2y equals -1. Now I can simplify. I've got 3y plus 2y combined. That gives me 5y's plus 9 equals -1. I want to get my 5y by itself, so I'm going to subtract 9 from both sides. That gives me 5y equals -10. 9 minus 9 is just 0. 5y plus 0 is just 5y. I'm going to divide both sides by 5, and we get that y is equal to -2, which is great. But now we want to plug this value for -2 back into one of the original equations. So I'm going to plug it into the second equation. So the second equation is x minus y, which is -2. That equals 3. So I get x, and then when I subtract a negative, it just becomes a positive. So I get x plus 2 equals 3. I'm going to subtract 2 from both sides, and I end up getting x equals 1. 3 minus 2 is 1. So we think right now that the solution is going to be 1, -2, but let's check our work, okay? Now remember, for 1, -2 to be the solution to the system, when I plug it into both equations in the system, it must make both equations true. So let's see what we get. For the first equation, I get 3 times x, which is 1, plus 2 times y, which is -2, equals -1. Well, excuse me, 3 times 1 is 3. 2 times -2 is -4. 3 minus 4 is -1, and -1 equals -1. So the first equation is good to go, but we have to check the second equation. So the second equation, I get x, which is 1, minus y, which is -2. Hopefully that equals 3. Remember, when we subtract a negative, it becomes addition. So I really get 1 plus 2 equals 3. And 1 plus 2 does, in fact, equal 3. So again, we can say with confidence that this right here, the ordered pair 1, -2, is in fact the solution to this system. Okay? So again, just to recap the method of substitution, you solve either equation for one variable. So pick an equation, pick a variable, solve. Again, make life easier for yourself. Look for equations where the coefficient on one of the variables is 1 or -1. Those are the easiest. Once you solve one of the equations for one variable, substitute that equation into the other equation, solve the new equation, use this value to find the other variable, check, and then write your answer as an ordered pair. Okay? So let's see. That's it for substitution for right now. Let's talk about steps for addition or elimination. So I am going to write these steps out a little differently than they're on your worksheet, but it'll be the same content. So steps for addition or elimination. Elimination. Okay, I'm first going to state what our goal is. So I'm going to redo kind of the steps for addition and elimination just a little bit. Our goal, just so you kind of know what you're working towards, is to force the coefficients of one variable to be opposites, so that if we add the equations, one variable is eliminated. So again, our goal is to manipulate these equations so that if you add the two equations, one variable gets eliminated. And the way we do that is we force the coefficients of one variable to be opposites, okay? So here's what we do. We multiply one or both equations by a non-zero constant so that one variable has opposite coefficients. Okay. 2, we then add the two equations. At this point, one variable should cancel. When we do this, we then want to solve. Okay, this gives us the value for the remaining variable. We're going to use this value from step 3 to find the other variable. We do that by plugging it into one of the original equations and solving. We check our work. And then my added step here is always write your answer as an ordered pair. Addition or elimination. Okay, so we're going to look at we're going to look at 3 examples of elimination. We're going to learn how to solve it kind of with 3 different situations that come up. We're going to check our answers, and that'll be the end of this video. And then the third video, we'll look at special cases. Okay, so let's go ahead and just dive in. We're going to solve using addition or elimination. And the first example is going to be an easy one. It's going to be one that's already set up where addition is going to work. And then we're going to look at the other 2 where we have to kind of manipulate the equations a little bit more. So for our first system, we have 3x plus 2y equals 14. And then we have 3x minus 2y equals 10. Notice, I'm going to go ahead and put this here. The coefficients on the x's are opposites. Okay, and that's exactly what you want. Okay, if I were to take these 2 equations right now and add them, okay, I'm just going to add the x's, I'm going to add the y's, I'm going to add the constants. I will, oh, please notice here, I made a tiny mistake. It's the coefficients on the y's are opposites. Please fix that in your notes. So the coefficients on the y's are opposites. So if I go ahead and I add these 2 equations vertically, that means I add the x terms, I add the y terms, I add the constants terms. Notice the y's are going to cancel out. So 3x plus 3x is 6x. Negative 2y plus 2y is plus 0y. 14 plus 10 is 24. Well, 0 times y is just 0. 6x plus 0 is just 6x. So what happens when you get the coefficients on one of the variables to be opposites, when you add the equations, that variable cancels out or gets eliminated, and then you have an equation with one variable that you can solve. I can solve 6x equals 24. So I'm going to keep solving. I'm going to divide both sides by 6. 6 divided by 6 is 1. 1 times x is x. 24 divided by 6 is 4. So I've got the first part of my ordered pair solution. We know that x is 4. We're going to now use this value for x. We're going to plug it back into one of the original equations, and we're going to solve for y. So let's say we do the first equation. So I get 3x, but x is really 4. So I get 3 times 4 plus 2y equals 14. Well, 3 times 4 is 12. That gives me 12 plus 2y is 14. I want to isolate the term that contains the y. So my issue is this 12. I'm going to subtract it. So 12 minus 12 is 0. 0 plus 2y is 2y. And then 14 minus 12 is 2. And then finally, to get y by itself, I'm going to divide by its coefficient. 2 divided by 2 is 1. 1 times y is y. and then 2 divided by 2 is 1. So we at this point think our solution is 4, 1, but we definitely want to check. Remember, an ordered pair is a solution if when plugged into the equations, it makes both equations true. So anywhere we see an x, we're going to plug in a 4. Anywhere we see a y, we're going to plug in a 2. So let's look at the first equation. I get 3 times x, which is 4, plus 2 times y, which is 1, equals 14. 3 times 4 is 12. 2 times 1 is 2. And then 12 plus 2 is 14. 14 equals 14. So the first equation is true. The second equation, let's check it. We get 3 times x, which is 4, minus 2 times y, which is 1, equals 10. Well, 3 times 4 is 12. Negative 2 times 1 is negative 2. 12 minus 2 is 10. 10 equals 10. So we can say with confidence the solution to this system of equations is the ordered pair 4, 1. Now, again, our goal when we're solving using elimination is to force the coefficients on one variable to be opposites. This one was already set up so that the y coefficients were opposites. So this one was pretty easy. The next one, we're going to have to do a little manipulating. So let's look at another example. So again, we're going to solve using addition or elimination. And it's depending on the book, some books call this the addition method, some call it the elimination method. I've seen it both in many different books. It depends, okay? Just know that they're the same thing, okay? And the system that we have this time is 4x plus 5y equals 3, and then 2x minus 3y equals 7. Now, notice the x's first. If I look at 4x and 2x, I could easily get the 2x to be a negative 4, which would make it an opposite of the first coefficient on x if I multiply the entire equation by negative 2. So if I'm going to try to eliminate a variable here, let's say we're going to look at eliminating the x's. I need the coefficients on the x's to be opposites. The first coefficient on the first equation for x is 4. I can force the second equation to have a coefficient of negative 4 for x if I multiply the entire equation by negative 2. So let's rewrite the system. First equation, we're not doing anything to it. It's going to stay 4x plus 5y equals 3. The second equation, we're going to multiply the entire equation by negative 2. Negative 2 times 2x gives me negative 4x. Negative 2 times negative 3y gives me positive 6y. Negative 2 times 7 gives me negative 14. So now if I go and I add the two equations, 4x minus 4x is 0. So I get 0x's plus 11y equals negative 11. Well, 0x is just 0. 0 plus 11y is just 11y. So this simplifies to be 11y equals negative 11. I want to get y alone, so I divide by its coefficient. Divide both sides by 11. On the left, 11 divided by 11 is 1. 1 times y is y. And then on the right, negative 11 divided by 11 is negative 1. So far, we think our ordered pair has a negative 1 for y. Now, we're going to take this value for y right here. We're going to plug it into either of the original equations, and we're going to solve for x. So let's say we do the first equation. So I get 4x plus 5y, but y is negative 1. We said that equals 3. So I get 4x, and then 5 times negative 1 is negative 5. Again, we say that equals 3. We want to get the 4x alone. I do that by adding 5 to each side. Negative 5 plus 5 is 0. 4x plus 0 is 4x. And then that should equal 8. Divide both sides by 2. 4 divided by 4 is 1. 1 times x is x. And 8 divided by 4 is 2. I think I said divide both sides by 2. We're actually dividing by 4, and we get x equals 2. So we think our solution is 2, negative 1, but we're certainly going to check our work. Now, once you get the hang of this, you don't have to check your work every single time, but it's a good habit to get into, to check every now and then, especially if you feel like an answer is a little off. Check it. It's pretty easy to do. Doesn't take that much time. So we're going to check, and we're going to check 2, negative 1. So anywhere we see an x, we're going to plug in a 2. Anywhere we see a y, we're going to plug in a negative 1. So I get 4 times 2 plus 5 times negative 1 equals 3. So it's going to be 8 minus 5 equals 3. 3 equals 3. The first equation is good. For the second equation, we get 2 times 2 minus 3 times -1 equals 7. Well, 2 times 2 is 4. -3 times -1 is +3. 4 plus 3 is 7. 7 equals 7. So this does, in fact, work. Okay. Now, let's just pretend that you didn't notice that you could pretty easily eliminate your x's. What if we wanted to eliminate y? So we originally had 4x plus 5y equals 3. And then we had 2x minus 3y equals 7. And let's say you didn't realize that you could just quickly multiply the second equation by -2. And you were like, I want to get rid of the y's. What you would do is you would look at the coefficients of the y's, 5 and 3. What is the smallest number that 5 and 3 divide into? Well, that would be 15. So what would I do to turn 5y into 15? I would multiply the entire equation by 3. And then if the coefficient on the first y is 15, the coefficient on the second y would have to be -15. So what would I do to get the second equation to have a coefficient of -15? I would just multiply it by 5. So the first equation would become 12x plus 15y equals 9. The second equation would become 10x minus 15y equals 35. And that's how you would manipulate the equation. So now if you add these two equations, the 15s would cancel. You can go ahead and try this one on your own. You'll get the same answer. So no matter which variable you try to cancel, the solution to this system is always going to be 2, -1. Okay? Let's look at one more example of this, and then we will wrap up this video. And the last video will be on special cases and word problems. Okay? So again, we're going to solve using addition or elimination. Okay, and the system that we have is 3x equals 2 minus 4y, and 5y equals -1 minus 2x. So I do want to make note here that these equations are not in standard form. If you look at the previous example, the equations here were in standard form. You had your x term plus or minus your y term equals your constant. We need that to be the case always. Okay, so we want to put these in standard form first. Okay, when they're in standard form, it's a lot easier to see what you need to do to the variables to make sure they cancel. Okay, so you want the x terms first, then the y terms, then the constant. So for the first equation, the 3x, let me just write it out here. To put this in standard form, we want to add 4y to both sides. That's going to give me 3x plus 4y equals 2. -4y plus 4y just becomes 0. For the second equation, we have 5y equals -1 minus 2x. I'm going to add 2x to both sides. That's going to give me 2x plus 5y equals -1. -2x plus 2x becomes 0. So my new system, even though it's the exact same equations, looks a little different. So my new system is going to look like 3x plus 4y equals 2. Second equation is going to be 2x plus 5y equals -1. It is really important for the addition and elimination method that your solution or that your system is written in standard form like this. Then you can start manipulating your equations. So at this point, you just decide, do I want to get rid of x's or do I want to get rid of y's? Let's just say that we want to get rid of x's. So if I look at the coefficients of x, I've got 3 and 2. So I would ask myself, what is the smallest number that 3 and 2 go into? That would be a 6. Okay. So what would I do? So I'm going to put a little note here. To eliminate x, the smallest number 3 and 2 go into is 6. So how do we make the coefficients 6, and negative 6. Okay, so let's say we want to just start by making the coefficients 6, and then we'll worry about the negative part in just a minute. So for the first equation, I would need to multiply the whole equation by 2 because 2 times 3x makes 6x. For the second equation, I would need to multiply the whole equation by 2 because 2x times 3 is 6x. The issue is one of the coefficients on x has to be negative. Doesn't matter which one. Let's say we make the first equation the negative 6x and the second equation positive 6x. So that means I'm going to multiply the entire first equation by negative 2. So let's see what this looks like. So 3x times negative 2 is negative 6x. 4y times negative 2 is negative 8y. 2 times negative 2 is negative 4. For the second equation, we can just multiply by positive 3 because, again, we want the signs on the coefficients of x to be different. So we're going to keep the second equation positive. So 3 times 2x is 6x. 3 times 5y is 15y. 3 times negative 1 is negative 3. So now if I add these two equations, the 6x's cancel. Negative 6x plus 6x is 0. And then I get negative 8y plus 15y. That just gives me plain old 7y. And then negative 4 plus negative 3 is negative 7. Divide both sides of the equation by 7. 7 divided by 7 is 1. 1 times y is y. Negative 7 divided by 7 is negative 1. So as it stands, we think the solution so far has a negative 1 for y. Now we want to find x. So let's say we take the first equation, 3x, and whenever we see a y, we replace it with negative 1. So I get 2 minus 4 times negative 1. So I get 3x equals 2. Negative 4 times negative 1 is 6. That's a lie. It's 4. Please don't hate me. So negative 4 times negative 1 is plus 4. So we end up getting 3x equals 6. We want to divide both sides by 3. 3's cancel, and we get x is equal to 2. So we think the solution is 2, negative 1. Let's go ahead and check our work. And this will probably be the last one where we check our work. I just want to make sure you see enough practice that you remember it. So to check, we're going to take both of the original equations. We're going to replace x with 2, y with negative 1. So I get 3 times x, which is 2, equals 2 minus 4 times y, which is negative 1. 3 times 2 is 6. And then I get 2, and then negative 4 times negative 1 is plus 4. I get 6 equals 6. First equation is good. Second equation, I get 5 times y, which is negative 1, equals negative 1 minus 2 times x, which is 2. So I get negative 5 equals, let's see, negative 1. And then negative 2 times 2 is negative 4. Negative 1 minus 4 is negative 5. Second equation is true. So we can say with confidence the solution here would be 2, negative 1. Now, for fun, what if we wanted to eliminate y's? So we had the system 3x plus 4y equals 2. And then 2x plus 5y is negative 1. And we chose right off the bat, let's get rid of the x's. But what if we had said, let's get rid of the y's? Well, what you would do is you would look at 5 and 4. The smallest number 5 and 4 goes into is 20. So we want to force the coefficients to be 20 and negative 20. So for the first equation, we would start by multiplying by 5 because 5 times 4y is 20. Second equation, we would start by multiplying by 4 because 4 times 5 is 20. But one of these has to be a negative. So we would just pick, let's say we chose the second one to be the negative. So then when you multiply the first equation by 5, and the second equation by negative 4, we get 15x plus 20y equals 10. And then we get negative 8x minus 20y equals 4. So your 20y's would cancel, okay? So just know it doesn't matter which variable you choose to eliminate, you're going to get the same solution either way. Just understand how to eliminate a variable. So look at the coefficients. Let me go to the screen. So when trying to figure out how to eliminate a variable with the addition method, look at the coefficients, figure out the smallest number that those two values go into, and that's what you're wanting to get the coefficients to be. Okay, so when we had 5 and 4, the smallest number 5 and 4 go into is 20. So we want the coefficients to be 20 and then force one to be a negative 20 if you don't already have opposite signs. Okay, so that's the second video in the system, in the series on systems. So the first video we just did kind of an overview of what is a system, what do the solutions look like, and then we did solve by graphing. Second video, this one, we just did the algebraic methods for solving, which were substitution and elimination. Make sure you know how to do both of those methods. You'll find with practice that certain systems of equations are just set up where elimination is going to be better. Some are set up where substitution is going to be better. It just depends. And then make sure you know how to check your answer. Okay, so that's it for this video. The next one we'll do special cases and a word problem. All right.